Okay, perfect. So by the end of the session, I would like to invite all the authors from the three paper back on camera. So we will have a very short panel discussion. Yeah, thanks, Irene. And yeah, okay. So I think in this session, all our three papers talk about the RDMA system from different dimensions. So I'm very curious to learn that what is your perspectives and what is your thoughts on new exciting challenges and opportunities that could fall into this RDMA system for the next generation. So yeah.
I'm happy to go first. So I think in a lot of ways, the RDMA hardware interface and technologies have been sort of used and abused for things that it was really not designed for. And I think in particular, what people wanted out of RDMA was kernel bypass as well as possibly CPU bypass, right? So there's sort of a range between people who want entirely CPU bypassing versus people who just want good latency. So what I'm really excited to see in the future is sort of what kind of slicing and dicing we could do of the primitives that RDMA offers. So for example, John had talked about how RPC-based systems are useful, right? One of the things that we found with demi-kernel was that it would be great if we didn't have to deal with acknowledgements and retries, because that's sort of out of band and things that add extra overhead. RDMA NICs already have the capability of doing that. They can do reliable transmission. And so I think it'll be really interesting as sort of the network technologies as well as the programmable hardware technologies go forward, as we make choices and move these guarantees around in terms of where they're going to be offered.
Mm-hmm. Yeah, thank you.
Okay, I'll go next. Can you hear me?
Yep.
Yeah. Yeah. So, in terms of, as in, I don't have a concrete answer for it, because, like, as Irene stated, like, you want like one-sided operations, and that require the NIC to actually know all the memory translation and memory permissions for all the registered memory regions. So that is like one problem, and it's kind of difficult to actually, if you don't have that in the cache, then how can the NIC do that quickly? So the benefit is kind of lost if that is not present in the NIC cache. So I am still, overall, what I'm seeing is, as in our work, what our aim is, like, you can somehow increase the scalability of like connected transport, but overall the way to go is like a hybrid of a datagram, somewhat like a connection free style and a connection based, so a mix of that, and based on your requirements, based on your applications, if it's possible to switch between the two dynamically.
Yep, thank you.
I can, both Irene and Sumit had really insightful answers. My take on this is there's a lot of work that is that's trying to extend one-sided operations, and there's also work that's trying to make networks faster. But there's also this, at some point, there's also going to have to be a redesign of applications in different ways so that they're actually exploiting the faster networks as well as the semantics of new one-sided primitives, possibly. And for me, it's a more complicated challenge than taking something that was running on a CPU initially and now running it on a smart NIC. Because I think that fundamentally doesn't change the CPU bottlenecks. It just changes where the bottleneck is, but not the fact that there is a bottleneck. So I think that's one of the interesting things I'd like to look at, is how you can really re-express a lot of the applications that were initial, like paradigms of applications, in ways that are actually exploiting these new networking paradigms.
Yep, thanks. Yeah, I see John is raising your hand. Yeah, please join.
Sure, if I can add my 2 cents worth this, I want to mostly reinforce what Irene said. I think the the big contribution of RDMA is to show us that there is an entirely new performance regime that we never experienced before by bypassing the kernel's first part, and second, moving the transport protocol entirely to the NIC. And both of these, I think, are essential going forward. However, I think we're going to find eventually that RDMA is actually not the right protocol, either from an abstraction standpoint or from an implementation standpoint. That's a much longer topic that I won't try and get into here. But I think the key thing is we have to move software transports to the NIC and bypass the kernel.
Right. And Edward, you want to add something?
Oh, no, I had another question for the panel. So I was thinking that all three of these systems are evaluated with relatively small RPC messages or transactions, and that's why the batching and coalescing matter. But is there a different approach you need to use when the data you're transporting is very large, or when the amount of processing that the receiver needs to do is significant, such that you wouldn't want to invoke that processing on the critical path? And a larger message exacerbates that problem, because if the effect of delivering the message is you now need to do some processing on a large amount of data, you might need to copy that data out of your RDMA buffer so that it can be used to receive another message. But the memcopy is a slow process that's actually now slower than the RDMA transport on a lot of CPUs.
I mean, I guess if you're talking about a large message with a lot of processing on the other end, I don't know that using any of these systems really matter, right? Because you're not waiting for a response very quickly, and you're not going to get one, right? And so then, like, going through the OS kernel is perfectly fine, right? Like, I don't think there's any reason to use all of these fancy technologies if you don't have to. And so that's why we really focus on things that where there's actually someone waiting for a response, right?
Okay. Trying to see if the other panelists have thoughts, but
Yeah.
Your concern was mainly about the time taken to do mem copies much more than the transfer itself. Is that correct?
well, that was just one concern that arises when you have larger messages being delivered to the server, and when the server receives it, it needs to do something with the message.
Yeah, but okay, I am actually not seeing what the problem is. Sorry. Yeah, so even if you not use RDMA or like use something else, DPDK or TCP, for example, then what is the difference? As in, what do you expect different if you use one of these systems and if you use a standard technology like that?
Well, I'm saying there is no current good solution for this, because you have to have your memory registered with the NIC to be used for RDMA. So you can't have a client process, the server software holding on to that memory for too long. And so you can't really have a zero copy RPC if the server needs to do any kind of processing with that memory for long enough that it needs to copy it out of that RDMA buffer.
So we actually do have integrated DMA capable memory, and there's no reason. So demi-kernel integrates a memory allocator exactly for that reason.
I was wondering about that. There wasn't enough details, but I was thinking, is this memory allocator to try to solve this zero copy problem?
Right, and so actually we have you might want to take a look. We have a paper in HotOS explicitly about RPC serialization and deserialization as well. Although we don't talk much about deserialization because we haven't done as much work there. But basically our idea well, one of the things that we're thinking about for our memory allocator is doing essentially IO working set estimation, where you have some idea of what memory pages the application's actually going to use for IO, and then we register just those pages. And so our current implementation in the C++ code, which we're moving away from, used Horde. And Horde is organized in super blocks, and we can just register an entire super block. Any sort of like memory pool based allocator would work there. So yeah, we can actually essentially just put data into application memory, and then the application can just use it. Like our Redis is 0 copy, for example, right? Like it just has a key value store, and the values are stored exactly where the NIC dropped them. There's a bit of memory fragmentation issues there, and yeah, lots of things to think about. And so we obviously haven't dug further into the sort of, I don't want to say black hole, but like, you know, we started tugging on this thread of memory allocation, memory management for kernel bypass and 0 copy, and a bunch of stuff came out, and, you know, it wouldn't all fit in this paper, but we're definitely still thinking about it for future work.
Okay. Yeah, that sounds really cool. And yes, this is a hard problem. It's not going to have a simple solution.
Okay, any other thoughts? Okay, so thanks for everyone that participated in the discussion of this session, and I will conclude the session. The next session, which is on flash storage, will begin in 5 minutes. So see you everyone there. Thanks.
That leads into my sort of panel questions. Since we have a couple minutes, I want to get this finished before the next session starts. So maybe very briefly, I'll challenge you. Is RDMA a good idea in hindsight? And we'll start with Irene and we'll go in order. So 1 minute on that, Irene.
Okay, yeah, I'm happy to talk about that. I also wanted to note for Soumya's, because you know we collaborated on this work. For Soumya's question, we also care about CPU usage, just period, right? So it's not only about latency. But yes, I really think that, you know, RDMA was a technology that was sort of used and abused for things that it was really not designed for. And, you know, that's not really the fault of anybody who built RDMA or the application programmers. It was just what was available at the time. But I think going forward, we should definitely try to design something better, because it's clear that you know, some amount of network offload into the NIC is going to be critical going forward. And I think, right, like the interesting work will be for, you know, the next N years, answering the question of what we should offload.
Thanks. Okay, Sumit, if you're still here, can you want to address that question? I'm not sure I see Sumit. Oh, he's just not, he's muted. Soumya, why don't you answer that one while we figure out what happened?
Yeah, all right, sure. So let's see. I mean, I'm pretty much new to the field, so please take all of my, everything I say with a grain of salt. But from what I hear, people keep saying networks keep getting faster and faster. So at some point, if you have terabit, like if you have 500 gig NICs, eventually you're going to have CPU bottlenecked applications, and you're going to have to think about ways in which you want to squeeze performance for an application, and RDMA seems like a viable target for that, especially for non-compute intensive applications. But with that said, it's still a non-trivial problem to solve, and I don't think we have all of the solutions yet.
Okay, unless Sumit can join us, I think we will wrap up now to give the next panel or session a chance to get started. Oh, there you are. Did you want to answer that question, or just let it go? And you're muted, sorry.
I'm sorry, yeah. Yeah, so I think the current state is such that I think there is too much of transport logic that I think is offloaded onto the NIC. For example, the work in ERPC, for example, on congestion control, I think that is, some of the things can be removed from the hardware itself and put on, as in can be abstracted as on the software side. That would have been much better. Another thing that I feel is That's all. Yeah. The second thing that I want is the way that applications are currently designed. For example, in terms of abuse of RDMA, as Irene was pointing, that's a good point in the sense that you need the primitives right now supported are not good enough to be used as in a holistic manner. In a holistic manner, it's hard to actually use those primitives. So what they have done in Prism, for example, giving a more higher level of primitives, higher set of primitives, I think that is something that can be done in hardware, and that would have been good. But as you know, as in the timeout, as in you develop a feature and that comes in hardware in several years. So I think I don't see that happening.
Okay,
in
I think,
years.
Speaking of timeouts, I think we are running up against the next session. So thanks everybody who participated, and I'll turn it over to the next session chair, whoever that may be.